Good evening, sir. You can start now, sir.
Okay, ma'am. Okay, ma'am.
Good evening, sir.
Yeah, Jay. Only you are there.
Yes, sir.
Okay. So we learned yesterday, day before yesterday, we learned crystal field theory. We learned valence bond theory, predicting the structures. Now, crystal field theory also we learned postulates. What are the postulates of crystal field theory? The first postulate in crystal field theory is the bonding between the metal and the ligand is completely electrostatic or ionic. This is the first point. First postulate. The second point, the same point, if I have to say, there are two types of metal ligand interaction. If it is a metal ion and the ligand is an anion, then it is called as ion-ion interaction. If you have a metal ion and if it's having a dipole moment, like water, it's a neutral molecule, but you can see oxygen is polar compared to hydrogen. So therefore, this kind of interaction, metal and the dipole interaction, this will be called as ion dipole interaction. And the third point is this d orbitals are 5d orbitals are there. They are degenerate, meaning they have same energy. When the ligand approaches them, they raise in energy. But when the ligands approach closer, they undergo splitting. We learned splitting in octahedral splitting as well as in square planar splitting. We learned, right? The lower energy is called as T2G. The higher energy is called as EG.
EG.
Yeah, EG. These are the postulates of crystal field theory. Now, based on crystal field theory and valence bond theory, we will work some of the questions. Right. So the first question, in valence bond theory, we know that the structure of a compound will depend on the hybridization. The structure of a compound depends on hybridization. Now, looking at the molecular representation, now you can see this looks complex. It takes time for you to understand. All right. But once you understand, you can answer these kind of questions easily. Now, one or two questions we will go in depth. We will learn. The hybridization involved in CO NH3 6 times 3 plus. The coordination number of cobalt is 6, meaning it should have octahedral geometry. Now, when I say octahedral geometry, it should be sp3d2 hybridization or d2sp3 hybridization. It cannot be sp3. See, here sp3d3 is 7 orbitals, not possible. Coordination number is 6. Here dsp3. It is 5. It is also not possible. Either from sp3d2 or d2sp3. From these only, the option A and B, option A and D, any one should be. Now the second point here is, now you should be in a position to identify the nature of the ligand. Ammonia is a ligand. Ammonia is a strong field ligand.
Yes, sir.
It's a strong field ligand. When ammonia is a strong field ligand, what will take place? Pairing of electrons within the metal takes place. When we say pairing of electron within the metal takes place, it means it goes against what would hunt. Now, what's the atomic number of cobalt? Atomic number of cobalt is 27. The electronic configuration of cobalt is argon configuration, 4s2 and 3d7. What is the oxidation number of cobalt? Oxidation number of cobalt. As a whole, the charge is +3. Ammonia is a neutral ligand, 0 into 6 is 0. Cobalt, we don't know, we take it as X, so X will be equal to +3. Oxidation number of cobalt is +3. When we say oxidation number of cobalt is +3, 4s2, these 2 electrons will be removed and 1 electron from here. Both the electrons from 4s, because outermost orbit is the 4th orbit. So 2 electrons from here and 1 electron from here will be removed. So what will be the electronic configuration of cobalt 3+? The electronic configuration of cobalt 3+ will be argon configuration and 3d6. Now, if I write argon configuration and 3d6, we know that d orbitals, 5 orbitals we have. 1, 2, 3, 4, 5, and 6. To create 6 vacant orbitals. Now, in order to create 6 vacant orbital, The next higher orbital possible is 4s, and the next higher orbital possible for this is 4p. Now, ammonia is what field ligand? Ammonia is a strong field ligand. Since ammonia is a strong field ligand, what should take place? Pairing of electrons should take place. Now, when I say pairing of electron will take place, this gets paired up here, and this gets paired up here. So, what will become the electronic configuration now? The electronic configuration will be 1, 2, 3, 4, 5. And next, what we have is 4p. Now, this 2d orbital, and 3p orbital, they evolve in hybridization to form 6d2 sp3 hybrid orbital. What will be the answer for this? The answer for this will be option B. Did you follow this?
Yes, sir.
Which of the following set of examples and geometry of the complex is not correct? Now you can see in the first case, in both the cases, coordination number is 6. When the coordination number is 6, the geometry is octahedral. Correct. Now, 2 plus. Both are having square.
Sir, your voice is not audible.
SP. The hybrid.
Sir, the voice is breaking, sir.
I don't know. Now it's clear.
Yes, sir.
Yeah. Okay. Yeah. I'm not well, so I'm talking a little slowly. All right. So here in both the cases, the hybridization. The hybridization of copper is DsP2 and nickel is DsP2. They have square planar geometry. Nickel tetracarbonyl and ZnCl2, ZnCl4 2 minus. In both the cases, the hybridization is sp3, therefore tetrahedral. Now coming to Fe NH3 6 times 2 plus and Cu Cl4 2 minus. See, trigonal bipyramidal. Trigonal bipyramidal is possible when the coordination number is 5. But here you can see coordination number is 6. Therefore, this will have octahedral geometry. Here the coordination number is 4 and it's a weak field ligand. When it's a weak field ligand, no pairing will take place. Therefore, it will have what geometry? Tetrahedral geometry. Right here, strong field ligand. Ammonia is a strong field ligand. Therefore, pairing takes place and the hybridization changes. Here the hybridization is sp3. And the wrongly matched option is option D, trigonal bipyramidal. Which of the following is correct? Which of the following is correct? Valence bond theory explains the colors of the coordination compound. Nickel tetracarbonyl, not carbonyl, nickel tetrachlorido, nickelate 2 minus is diamagnetic in nature. All right. Ambidentate ligand show linkage isomers. A bidentate ligand can have 4 coordination sites. So bidentate ligand will have only 2 coordination sites. It'll have only 2 coordination sites. Now, how do I find whether it's diamagnetic or paramagnetic? What's the atomic number of nickel? The atomic number of nickel is 28. The electronic configuration of nickel is argon configuration 4s2 and 3d8. The oxidation number of nickel is +2. +2 means this 2 electrons will be removed. So what will be the electronic configuration of nickel 2 plus? It will be argon configuration and 3d8. When I say 3d8, now I write like this. D subshell has 5 orbitals. 1, 2, 3, 4, 5, 6, 7, and 8. Now, chloride is weak field ligand. When chloride is weak field ligand, will pairing take place? Will pairing take place? Chloride is a weak field ligand. Will pairing of electron take place within the metal?
No, sir.
No, that means 2 unpaired electrons are there. When 2 unpaired electrons are there, it will be paramagnetic. But here they mentioned as diamagnetic. This is also wrong. All right. Valence bond theory explains the color of what? Coordination compound. Valence bond theory never explains the color. That is a demerit of valence bond theory. Now, ambidentate ligands show linkage isomers ONO minus NO2 minus. Here nitrogen is a donor atom, here oxygen is a donor atom. The molecular formula is about NO2. Ambidentate ligands, or ligands which have more than one type of donor atom, is called as ambidentate ligand. Did you follow this? Students?
Yes, sir.
Yes, sir.
Mark the incorrect statement. Mark the incorrect statement. The inner orbital low spin complex involve D2 sp3 hybrid orbital. Outer orbital high spin complex involve sp3 D2 hybrid. Tetrahedral complex generally involves dsp2 hybridization. Stereoisomerism involves geometrical and optical isomerism. See, when we say low spin, this is 3d electrons, this is 4s electrons, and this is 4p. Outer is 4, but 3d electrons, n-1 electrons are involved here. Therefore, it's called as inner complex. This is correct. So high spin complex, outer spin complex, this is 4s, this is 4p, and this is 4d. So therefore, this is also outer complex. Outer orbitals are involved. Therefore, it will be called as outer complex. Now, tetrahedral complexes generally involve what hybridization? Tetrahedral complex. Tetrahedral molecules will have what hybridization? They will have sp3 hybridization. They will not have dsp2. dsp2 hybridization is for square planar structure. So whenever we have dsp2 hybridization, the structure is square planar. Here they have mentioned tetrahedral complexes. These tetrahedral complexes generally will involve dsp2 hybridization. The next question. Are you following, students?
Yes, sir.
Which of the
Yes,
following facts? Yeah, which of the following facts about complex CrNH3 6 times Cl3 is wrong? Which of the following is wrong? The complex involves D2sp3 hybridization is octahedral. It is octahedral, sure. The complex is paramagnetic. The complex is an outer complex, and the complex gives white precipitate. That quickly you tell me. Just observe the molecular representation and tell me what is the wrong option here. Quickly. Now, ammonia is what type of ligand?
Neutral ligand.
Neutral ligand. Whether it's a strong ligand or weak ligand.
So strong, sir.
When it's a strong ligand, what will happen? Pairing of electron within the metal takes place or not?
Takes place, sir.
When the electron pairing within the metal takes place, so what will happen? N-1 d orbital will take part in the hybridization, 4s and 4p. Since N-1 d orbitals are taking part in the hybridization, this will be called as what complex? It will be inner complex. The hybridization will be D2sp3. So it's not an outer complex, it's an inner complex.
Yes, sir. Option C is wrong, sir.
Option C is the wrong one. All right. Which of the following complex will have tetrahedral shape? Which of the following will have tetrahedral shape? Now, there is two possibilities. What are the two possibilities here? See, all the molecules have coordination number 4. So when all the molecules have coordination number 4, there is two possibilities. One is tetrahedral, or the other one you will have what? Square planar. Other one will have square planar. So two types of structures possible. Now, which will have tetrahedral geometry, they're asking. Tetrahedral geometry. Now, if I take a molecule, since I know the answer, I will write the NiCl4 2 minus. Now, nickel atomic number is 28. The electronic configuration for nickel is argon configuration 4s2 and 3d8. Nickel oxidation number is +2. Oxidation number of nickel is +2. But these two electrons are removed. So nickel 2 plus will have oxidation number. What's the electronic configuration? Argon configuration 3d8. Now 3d8, if you write like this, we have 1, 2, 3, 4, 5, 6, 7, 8. 2 electrons are there. Now, since the coordination number is 4, the central metal nickel has to generate 4 vacant orbitals. What are the 4 vacant orbitals it can generate? It is 4s and this is 4p. So here the hybridization will be sp3 hybridization. When the molecule undergoes sp3 hybridization, the shape of the molecule is tetrahedral. So in nickel, this complex, NiCl4 2 minus, tetrachloronickelate 2 minus, the hybridization of nickel is sp3. Therefore, this will have tetrahedral geometry. All these will have dsp2 hybridization. So all these will have a square planar geometry. Did you follow?
Yes, sir.
Yes, sir.
Next question. The complex ion which has no d electron in the central metal. The complex ion which has no d electron in the central metal. Tell me, which is the complex ion which has no d electron in the central metal? Now, firstly, I'll take an example. Not example, we'll take MnO4 minus. What is the oxidation number of manganese here? As a whole, the charge is -1. Oxygen is -2. -2 into 4 is -8. Manganese, we don't know. We take it as X. So X will be equal to +7. Oxidation state of manganese is +7. If you take a neutral manganese, the atomic number of manganese is 25. The electronic configuration will be argon configuration 4s2 and 3d5. This is the electronic configuration of neutral manganese atom. Now, since manganese has 7 plus charge here, so 7 electrons has to be removed. What are the 7 electrons? 2 electrons from S and 5 electrons from D. All these 7 electrons will be removed. When all the 7 electrons will be removed, the configuration of argon, configuration of Mn7 plus is only one argon configuration. So this does not contain D electrons. D electrons. Hence, the answer for this question is option A. You should work out for the other complexes. Only then you will be in a position to answer the questions in the exam. Just if you are following what I'm teaching, and if you just forget and not forget, and if you just understand only the concept and leave, you will be forgetting it in the exam very easily. So you need to practice for the other options. You should check what is the oxidation state of other metal ions, all that. Now, give reasons for the statement. NiCl4 2 minus is diamagnetic, while NiCl4 2 minus is paramagnetic in nature. Tell me what will be the answer. Quickly. You know this. I don't want to teach again the same thing. Please tell me. Read the options and tell me. You should give me your reasons also. Read the options and tell me which is the right answer.
Sir, is it option A?
No, it is not option A. Now you should identify here. Cyanide is a strong field ligand and chlorine is what? A weak field ligand. So ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ pairing ಆಗುತ್ತೆ. So nickel atomic number ಬಂದು 28. Again nickel has what? 2 plus configuration. So oxidation state. So it will be argon configuration and 3d8. If you write like this, 5 orbitals having 8 electrons, 1, 2, 3, 4, 5. 5 and that's that 6, 7, 8. Right, for this complex we will see. Now the next higher orbital is 4s and the next higher orbital possible is 4p. Since cyanide is a strong ligand, pairing adre, the molecule will be what? Diamagnetic, because no unpaired electron. But in this complex, chlorine is a weak field ligand. Pairing will not take place. Therefore, this is paramagnetic in nature. So what will be this? In case of the nickel complex, no unpaired electrons are there because of pairing due to the cyanide strong ligand. But in case of NiCl4 2 minus, pairing will be unpaired electrons will be there because chloride is a weak field ligand. No pairing will take place. Therefore, therefore the answer for this question is option B.
B, sir.
Followed this? Followed with this?
Yes, sir. Yes, sir.
All right, the lowest value for the paramagnetic, where is that? Lowest value of paramagnetism is shown by, how do you show paramagnetism? Paramagnetism is based on what number of unpaired electrons. More the number of electrons, more will be what? The magnetic property. Lesser the unpaired electron, lesser will be what is the magnetic property, paramagnetic character. Now, cobalt night cyanide, this one if you take, cobalt has atomic number 27. Oxidation number of cobalt is 3 plus. The electronic configuration of cobalt is argon configuration 3d6. Now, if I represent the d orbitals like this, 6 electrons like this, 3, 4, 5, and 6. This is 3d. Next is 4s, and next is 4p. Now, cyanide is a strong field ligand. In all the cases, it's strong field ligand. So, cyanide is a strong field ligand. What happens? Pairing will take place. Now, when pairing takes place, what happens? It will have no unpaired electrons at all. When it has no unpaired electron, then the paramagnetism will be what? Minimum for that. Therefore, this complex will show lower paramagnetism because no unpaired electron. This has what? No unpaired electrons. Due to what? The cyanide ligand. Cyanide ion, when it approaches, what happens? Pairing of electron within the metal takes place. Followed. The next question. POF63 minus. Tell me what will be this. You should tell me the answer for this question. Just now we learned cobalt complex. We learned with ammonia, but here it is with fluoride. Tell me what will be the hybridization, what will be the nature, whether it's paramagnetic or diamagnetic. What will be the answer? What is the coordination number of cobalt here? The coordination number of cobalt here is 6.
So 6, sir.
That means the third and the fourth option is ruled out because they say sp3 hybridization. It's only for coordination number 4. Since coordination number is 6, it can be either sp3d2 or it can be d2 sp3. Now you tell me which one, which is the answer, A or B. You should give me the reason. A or B. It's okay. You take a guess and give me a reason.
So B, sir.
It is B. Why it is B? Now cobalt is 27 and cobalt has oxidation number +3. The electronic configuration of cobalt is argon configuration 3d6. Now when we say 3d6, we write 6 electrons like this. 1, 2, 3, 4, 5, and 6. The next higher orbital is 4s and the next higher orbital is 4p. Now in the first, fluoride is a weak field ligand. When fluoride is a weak field ligand, what happens? No pairing of electrons takes place. No pairing of electron takes place. The pairing will not take place. When this is not taking place, what is the next higher orbital possible? The next higher orbital possible is 4d. When we say 4d, now what happens is one electron, one orbital from S, 3 orbital from here, P, and 2 orbital from here. Totally 6. So what will be this? sp3 d2 hybridization. And this will be paramagnetic. Why it is paramagnetic? You can see that clearly there is unpaired electrons. 4 unpaired electrons you have. Therefore, it will be what? Paramagnetic. Hence, the answer for this question is option A. Did you follow, Ajay? And Lakshmi?
Yes, sir. Yes, sir. Followed, sir.
Yes, sir.
The next question. The magnitude of magnetic moment, spin only, in NiCl4 2- will be. What is the magnetic moment? How do you calculate magnetic moment? What is the formula to calculate magnetic moment? Mu is equal to square root of n into n plus 2. N stands for number of unpaired electrons. Number of unpaired electrons. In NiCl4 2-, the charge on nickel is +2. The electronic configuration of nickel is argon configuration 3d8. Now, when we write 3d8, 5 orbital, if I write like this, 5 orbital, 1, because chlorine is a weak field ligand. Chlorine is a weak field ligand. Since chlorine is a weak field ligand, what happens is no pairing of electron will take place. Therefore, these 2 unpaired electrons are there. N will be what now? 2. So what will be mu now? Square root of 2 into 2 plus 2. It will be square root of 8. Square root almost equal to 2.82 Bohr magneton. So it will be 2.82 Bohr magneton. So root 9 is what? 3. Root 8 will be little lesser than that. That's how you have to take a guess. So the answer for this question is option. Did you follow?
Yes, sir.
The next question, which of the following has highest paramagnetism? Which of the following has highest paramagnetism? Can you tell me which of the following will have highest paramagnetism? What to do for that? You have to find out the number of unpaired electrons in each central metal: chromium, iron, copper, and zinc. So you know how to find. I'll work it only for chromium, and otherwise you have to work. All right. Now, chromium atomic number is 24. The electronic configuration of chromium is argon configuration 4s1 and 3d5. The oxidation number of chromium is +3. So 1 electron from here, 2 electrons from here will be removed. So chromium 3+ will have the electronic configuration, argon configuration, and 3d3. 3d3. So in the d subshell, you will have 3 electrons, 1, 2, and 3. 3 electrons like this. The next is the 4s. The coordination number is 6. So next is what 4s and 4p, all that, you know. So this has what 3 unpaired electrons. So chromium has 3 unpaired electrons. Iron, if you look out for iron, likewise, iron will have 4 unpaired electrons. 4 unpaired electrons. Copper will have 1 unpaired electron, and zinc will have 0 unpaired electron. Now tell me which will have the highest paramagnetism. Which has the highest paramagnetism? Which has more unpaired electrons? Fe2+ has what? More unpaired electrons. Therefore, the highest paramagnetism will be shown by the complex B. Did you understand what I was talking? Yes?
Yes, sir.
Yeah, the next question. Using valence bond theory, the complex CrNH3 6 times 3+ can be described as, using valence bond theory. Tell me, this we have learned, we are learning chromium metal, no? You tell me now. What will be this? Take a chance and tell me. You have to give me the reason also. Now, since it is coordination number is 6, the structure is octahedral, no doubt. When the structure is octahedral, we talk about inner complex and outer complex. Now, ammonia is a strong field ligand. When ammonia is a strong field ligand, pairing of electron within the metal takes place. Now, tell me, what will be the answer? Just now we learned, in case of chromium, the chromium oxidation number is 3+. So D subshell has 3 electrons. 1, 2, 3 electrons. And this is 4s and this is 4p we learned. Now, sorry, ammonia is a strong field ligand. Since ammonia is a strong field ligand, what happens? This will get paired up. Excuse me. This will get paired up. When this gets, oh my God, oh shit. This will get paired up. But still, this will remain unpaired because only 3 electrons are there. Only 1 electron gets paired up. The other remains unpaired. When other remains unpaired, it will be paramagnetic. So we conclude it either A or C. The answer should be from either A or it should be from C. Now you tell me what will be the answer. More, whether it's outer complex or inner complex. Now see, these d electrons are vacant now. Since these d electrons are vacant now, it will be D2sp3 hybrid. This is inner complex. So answer will be what? Option C. Option C. And I have to make a point here. I made a mistake. The mistake is if they are pairing, even though cyanide ammonia is a strong field ligand, here pairing will not take place. Pairing will not take place because even though this gets paired, what happened? This remains unpaired. Therefore, in this case, chromium pairing will not take place. 3 unpaired electrons will be there. So D2, S and P orbitals. Therefore, the hybridization is D2sp3. So this the answer for this is inner complex D2sp3. All right. All right. Next, are you there?
Yes, sir.
Yes, sir.
Yeah. Among NiCO4, NiCN4 NiCl4 species, the hybridization state of nickel atom are, respectively. Nickel atomic number is 28. Tell me what will be the hybridization of nickel. Here, nickel tetracarbonyl is a tetrahedral complex. It is sp3. All right. Now here, this is square planar. NiCN4 is square planar. So therefore, the hybridization is dsp2. Right. Now, coming to the third, NiCl4 This also undergoes sp3 tetrahedral. Therefore, answer is option B. We worked out these questions, right? That is why I'm just giving the answer directly. All right. So answer will be option B. You should write the electronic configuration of nickel, oxidation state of nickel, and lone pair. All that you should check. All right. Next. Considering water as a weak field ligand. Considering water as a weak field ligand, the number of unpaired electron in MnH2O 6 plus will be. Manganese atomic number is 25. The oxidation state of manganese is +2. The electronic configuration of manganese is argon configuration 3d5. Now 3d5, when we say 3d5, so d subshell has 5 electrons. 1, 2, 3, 4, and 5. It has 5 unpaired electrons because water is considered to be weak field ligand. Since water is considered to be weak field ligand, no pairing will take place. Therefore, it will have 5 unpaired electrons. Hence, the answer for this question is option B. Option B. All right. The next question, 16th question. Cyanide Cn minus is a strong field ligand. This is due to the fact that it carries negative charge. It is pseudo halide. It can accept electron from metal species. It forms high spin complex. What is the answer? What's the answer for this question? Cn is a strong field ligand. This is due to the fact that it carries a negative charge. It is a pseudo halide. All right. Now, we have not heard a word called a pseudo halide. What is the pseudo halide? It is an ion. It's an ion with strong coordinating ligands. It's a strong coordinating ligands. Strong coordinating ligands. And they have the ability to form sigma and pi bond. And they have ability to form sigma and pi bonds. So only cyanide ion is a strong field ligand. It can form both sigma and pi bonds. And it's a strong coordinating ligand. Those kind of ligands are called as pseudo halides. So strong cyanide is a strong field ligand. This is due to the fact it is a pseudo halide. It's a pseudo halide. The next question. Atomic number of chromium in the iron are 24 and 26. Which of the following is paramagnetic? The spin of, with the spin of the electron. Paramagnetic and with the spin of the electron. Tell me which will be paramagnetic. Oh my God. Which of the following will be paramagnetic? Now we will take the answer and solve it. Chromium complex. Last complex. Ammonia complex. So ammonia is a strong field ligand. Carbon monoxide is also a strong field ligand. But it's a neutral complex. There's no charge here. These two are neutral complex. Now, chromium, atomic number is 24. The electronic configuration of chromium, we learned chromium has 3 plus charge. It will be 3d3. If we write it like this, 3d3, even though ammonia is a strong field ligand, pairing will not take place. When pairing will not take place, which involves the hybridization, this 3d and 1s and 3p. So the hybridization will be D2sp3. It forms an inner complex. See, atoms, ions, or molecules having unpaired electrons are paramagnetic. So here you can see 3 unpaired electrons this complex has. Therefore, it will be what? Paramagnetic. Hence, the answer for this question is option D. Followed?
Yes, sir.
Okay.
Yes,
The
sir.
next complex out of TiF6 2 minus 2 minus COF6 3 minus Cu2Cl2 and NiCl4 2 minus. Atomic number of titanium is 22, cobalt is 27, copper is 29, nickel is 28. The colorless species is, which is the colorless species? Work it out and tell me. I know that I'm not taught you. All right, you just try to work it out and tell me which is colorless. Let's see. Let's see how we work this one. I'll give you 2 minutes. Take out your notebooks and work it out and tell me. You should give me the reasons also. Did you work out of PiF62 minus, COF63 minus, Cu2Cl2, NiCl42 minus? The colorless species is. Unpaired electron should not be there. If you have unpaired electron, it will undergo DD transition. It will become colored. So if there is no unpaired electron, DD transition is not possible. So tell me which is colorless here. Or no d electron should be there. One more reason. Kindly work it out and tell me. Oh God. Is there any clue? Is there any clue? Titanium F62 minus.
Sure.
This is the complex. Titanium,
Yes,
now
sir.
as a whole, the charge is -2. Fluid is -1 into 6 is -6. Titanium, we take it as X, so X will be equal to +4. Atomic number of titanium they've given us a 22. So oxidation state of titanium is +4. Titanium as the electronic configuration, argon configuration, 4s2 and 3d2. Now since oxidation number is +4, all these electrons will be removed. So titanium 4 plus will have only argon configuration. So no
Yes,
d
sir.
electrons. No d electrons.
Yes, sir.
Since there is no d electrons, it will be colorless.
Colorless, sir. Yes,
Yeah.
sir.
Again, if you see Cu2Cl2, that is Q
Sir,
plus.
sir, option C, right, sir?
Yeah. Copper atomic number is 29. Here the atomic number of copper is +1, oxidation state. So electronic configuration of copper is argon configuration, 4s1, 3d10. Now since +1, this electron will be removed. So it will have 3d10, completely filled d orbital. When you have completely filled d orbital, dd transition is not possible. So therefore, this also is colorless. So the option will be what? C, titanium F62 minus and CuCl2. All right. The next question. What's the next question? Which of the following complexes exhibit the highest paramagnetic behavior? Where GLY is glycine, EN is what? Ethylene diamine, BPY is bipyridal moieties, right? And question. It requires complete explanation in this because I should explain what type of ligand is GLY, what type of ligand is pyridine, all that. All right, it takes time. So 19th question, we're going to do it in the next class. The 20th question, you see shape of I gave you this answer today. Today I gave this answer. Can you recall number of iron? What's the coordination number of iron? What's the coordination number of iron? Huh? What's the coordination number?
+1.
Coordinate.
So 5, sir.
So,
And it's a neutral complex, remember. When the coordination number is 5, the hybridization is DsP3. When the coordination number is DsP3, you have CO, CO, and CO in plane. These all are in one plane. It's in the form of a triangle. One number is 5. The structure of the
So your voice is breaking.
option C. Yeah. Okay. Okay. Which of the following will exhibit maximum ionic conductivity? Which will show maximum ionic conductivity? K4 will dissociate to form 4K plus and FeCN6 4 minus. This one will dissociate to form CONH3 6 times 3 plus plus 3Cl minus. This will dissociate to form Cu NH3 4 times 2 plus and 2Cl minus. And this is a neutral complex. Neutral complex. It will not give ions. Now tell me which will have highest conductivity. Now the first case, totally we have
Sir,
how many
A.
ions? We have 5 ions. Oh, 5. 4 plus 1, 5. Second case, it is what? 4 ions. 1 plus 3, 4 ions. And the third, it is what? 2 plus 1, it is 3 ions. It is 0 here. So which will have more ionic conductivity? Conductivity is based
Option
on
A, sir.
ions. Option A, greater the number of ions, greater will be the conductivity. Hence the answer for this is option A. Tell me what is the coordination number of nickel here in the complex? NiC2O4 thrice. What is the coordination number of nickel? What is the coordination number of nickel? Ajay, Dhanlakshmi, quickly. This simple question. What is that C2O4? What type of ligand is that? What's the name of that ligand?
So
What's the name of that?
oxalate.
Oxalate. Oxalate is what type of ligand? Is it a monodentate or bidentate?
So bidentate, sir.
When I say bidentate, each oxalate behaves like 2 monodentate. So what's the coordination
Yep.
number?
So 6.
What's the coordination number?
6.
Yeah, coordination number will be what? 6. Because it's a bidentate ligand. So 2 into 3 will be what? 6. The next question. The coordination number and oxidation state of chromium. Find out what is the oxidation state of chromium and coordination number. Coordination number is 6. Oh, when coordination number is 6, it's oxalate ion. So coordination number is 6 means only one option is there plus 3. So it will be answer C. All right. Just now we learned with oxidation number of was it coordination number of chromium. Was it oxalate? 6. Now tell me the magnetic moment of a 1.73 Bohr magneton will be shown by one of the following. Which will show? Tell me. Magnetic moment. So magnetic moment will be one of them will be shown by. So where is this called? 1 minute. So far it was good. Yeah. Now it is mu is equal to square root of n into n plus 2. Now they've given mu as 1.73. That will be equal to square root of n into n plus 2. Squaring both the sides. Solve for n. When you square both the sides, you get 1.73. The whole square is equal to n into n plus 2. So solving for n, if you solve for n, you get n is equal to 1. You get n is equal to 1. So in case of this complex, number of unpaired electron is 1. Here number of unpaired electron is 2. Here unpaired electron is 0. And here in this complex, the number of unpaired electron is 3. So which will show now the square root of 1 into 1 plus 2 is what? Root 3 is 1.76. So number of unpaired electron is what? 1. So option A will show what? The magnetic moment as what? 1.73. All right. I want you to give the next question answer. Let's see. Please read the question carefully and answer me. This is based on Werner's theory. Please concentrate and work it out and tell me. The correct order of the stoichiometry of AgCl formed when AgNO3 in excess is treated with complexes. See the first complex, you can write CO, NH3, 6 times Cl3. They have not mentioned it clearly. They have given us a molecular formula. This is the first complex. Second complex is the CO, NH3, 5, Cl, and Cl2. The third one is CO, NH3, 4 times Cl2 and Cl. All of this will react with AgNO3 to give 3 moles of AgCl here because 3 free chlorine atoms are there. Here, how many free chlorine? 2. Therefore, it will react with 2 moles of AgNO3 to give 2 AgCl. And here only 1 chlorine because these all are behaving like ligands. So only 1 silver nitrate. So to give 1 mole of AgCl.
Sir, option C.
Huh?
Option C.
Option C, na? I don't know where it's. Yeah, it is what option C. All right. Madam, will stop today. All right. Not keeping well. Madam, kindly help me, ma'am. Ma'am.
Yes, sir.
Stop, ma'am.
Thank you, sir.
Thank you, sir.
Okay, ma'am.
Thank you, sir.
Yeah, bye, man. Bye. Okay.